In this lesson, we are going to see how to use the geometric characteristic symbols in GD&T. The geometric characteristic symbol is divided into 5 types and 14 symbols in total as per ASME standard. The feature control frame is represented as shown in the picture. It is comprised of many compartments. The first compartment we call it as the geometric compartment, where we specify the symbol or the shape tolerance. The second compartment is called as a tolerance compartment, where we represent the size of the tolerance as well as the material modifiers. In case if the shape is a circular shape, then we will include the dia symbol. The next 3 blocks we call it as the datum compartment. The datum can be a primary one or secondary one or tertiary one. So it is represented in the order as shown in the picture. We will discuss these 14 symbols one by one. First, let us discuss about the form controls. As it is mentioned, form control controls the shape of the feature. There are totally 4 kinds of form control: straightness, flatness, roundness and cylindricity. In this, straightness and roundness is a 2D control, whereas flatness and cylindricity will be a 3D control. Let us discuss what is meant by a straightness control. The straightness is represented with a symbol as shown. Straightness is a condition in which the elements of a surface or its axis are in a straight line. The axis or the edge of a surface can be deviated within a tolerance value. You can see in the picture, the straightness symbol is applied to a feature. In this case, it is representing an axis. The axis can have a deviation within a zone. That zone is called as a tolerance zone. The distance of the tolerance zone, we call it as a tolerance value. The straightness condition can be inspected by the methods as shown in the picture. To conclude about the straightness condition, the straightness condition can be applied for a cylindrical axis or to check the straightness of a flat object. The straightness symbol should be applied only on a feature. It cannot be applied for a feature of size. A straightness symbol does not require any datum condition, and modifiers can be applied to the straightness condition. Now we discuss on flatness. The flatness condition is represented by the symbol as you see in the picture. Flatness defines how a surface is deviated with respect to the perfect plane. The flatness control is a 3-dimensional control. It consists of 2 parallel planes within which all the surface irregularities should lie. The distance between the parallel plane is equal to the flatness control geometric tolerance value. The flatness control cannot have any material modifiers. It is applied only on RFS condition. The application for a flatness symbol, it can be used for representing the flatness of a gasket or a seal, or you can use this flatness symbol to represent the flatness of a mating part, or the flatness symbol can be used to check out the better contact with another datum plane. The flatness symbol should be only used with a feature. It cannot be applied with the feature of size. Datum is not required for a flatness condition, and since it can be implied only on RFS, modifiers cannot be applied for the flatness condition. I hope you understood the straightness and the flatness condition. In workshop number 12, you are given 2 drawings and the question is given. Checking the picture, you have to answer the questions which is given there. Once you completed it, you move on to workshop number 12A. So you have to fill in the questions. The picture is given for reference. Once you complete this workshop, you can refer the answers in the completed datasheet available in ORG site. Next, we move on to the next condition, the circularity condition. The circularity condition is represented by the symbol as shown in the picture. Circularity defines how much a circular element can vary from a perfect circle. This control are used to define the shape of a feature in relation to itself, and also it can be used as a datum. From the figure, you can observe that the circularity condition can be applied to both a feature as well as for a feature of size. The picture in the figure indicates what are the inspection methods available for checking the circularity condition. To conclude it, the circularity conditions can be applied for shaft and cones. This symbol can be used both for feature and feature of size. Datum cannot be added to the circularity condition, and since it can be implied only on RFS, modifiers cannot be applied. The flowchart in the screen gives an idea how the circularity conditions can be applied. First, you have to check whether a datum reference is specified. If the datum reference is specified, then you cannot apply a circularity condition to the geometry. If the datum reference is not specified, then you go for the second check, or the any modifier specified. If any modifiers are specified, then the circularity condition cannot be applied, so you can ignore the application of circularity there. In case if no modifiers are specified, then you go for the third check whether this condition is applied for a circular element. If it is for a circular element, then you can go for the next check. The next check is the tolerance value for a circularity condition should be less than that of the diameter tolerance. If the condition is true, then go for the next check, else you can terminate at this point. Then the next check is whether it is a refinement of an existing control. If it is so, then you are giving a legal specification for circularity control, else it's not applicable. Now you have to complete workshop number 13. In workshop number 13, the drawing is given and questions are asked based on the drawing. After completing this activity, you can check the answer in the completed drawing sheet available in ORG site. The next condition is cylindricity. The cylindricity tolerance is applied with the symbol as shown in the picture. Cylindricity is a condition where the surface of revolution in which all points of the surface are equidistant from a common axis. It is applied simultaneously on the entire surface. The cylindricity condition is generally applied on shaft. The cylindricity condition is applied on the feature and not for the feature of size. We do not require a datum to apply the cylindricity condition. Since it can be implied only on RFS, modifiers cannot be applied for the cylindricity condition. The flowchart given in the screen checks whether the cylindricity condition is a legal specification or not. Now you can start working on workshop number 14. In workshop number 14, a drawing is given and questions are asked based on the drawing. Once you complete this activity, you can check the final answer with the completed drawing sheet available in ORG site. Next we discuss about orientation controls. There are three types of orientation controls. We call it as perpendicularity, angularity and parallelism. The orientation tolerance specifies how far the actual orientation between the two features is permitted to deviate from the perfect orientation or the datum, or you can say it is a deviation from the nominal form. Orientation deviation must be related to one or more other datums. The datums must be defined first before an orientation tolerance can be specified. Let us discuss the first orientation condition, which is perpendicularity. The perpendicularity can be compared to both straightness and flatness depending on the feature being controlled. Perpendicularity may be specified to control four types of feature, that is surface, axis, line or median plane relationship. When control is specified to plane or surface, the control can be related to flatness. When the control is specified for element, axis or median plane, it can be related to straightness. The picture in the screen represents how the perpendicularity condition is represented. From the symbol, you can see the perpendicularity condition can be applied to both the feature and the feature of size. To conclude, the perpendicularity condition can be applied for L angles and brackets. It can be applied to feature as well as feature of size. To represent the perpendicularity condition, we require a datum, and modifiers like tangency, MMC and LMC can be applied to this perpendicularity symbol. The next symbol in the orientation is angularity. It is represented by the symbol as shown in the picture. It is a condition of a surface, axis or central plane which is at a specified angle from a datum plane or axis. Angularity control controls all angles other than 90 degree. Angularity is similar to flatness when controlling surface with related to a datum. When angularity is specified for cylinders or non-cylinder features, a line or medium plane is being controlled like straightness along with the datum relation. You can see first we have to represent the datum and then we have to represent the angular value, and it should be a basic dimension, and then the angularity symbol should be represented. The angularity condition can be represented to feature as well as feature of size. To conclude, the angularity condition can be applied for angular brackets. It can be applied for both feature and feature of size. You require a datum for representing the angularity condition, and modifiers can be applied for angularity. The third one in the orientation control is parallelism. Parallelism provides a zone defined by two parallel planes or lines or cylindrical parallel to a datum plane or axis within which the surface elements or the axis must lie. You can see that the parallelity condition can be represented for an axis. The axis should be parallel to a plane, and you should represent the parallelity condition with a datum prefixing it. The parallelity condition can be applied for flanges and connecting rods. It can be applied for both feature and feature of size. You require a datum for applying the parallel condition, and modifiers can also be applied for a parallel condition. Next comes the location control. Location tolerance defines maximum permissible deviation from this normal position. It includes position, concentricity and symmetry. The characteristic of location control are a center distance between features such as holes, slots, bosses, tabs are applied. It represents the coaxiality of the features. Now let us discuss the first condition in location control, which is concentricity. Concentricity is a condition where the median points of all diametrically opposite elements of a cylinder are congruent with the axis of a datum feature. This kind of condition is mostly used for stepped shaft. To represent the concentricity condition, first we have to represent the datum, and this concentricity condition can be applied only for a feature of size. The concentricity condition can be applied for cylindrical features. It cannot be applied for a feature. It can be applied only for a feature of size. It requires a datum for representing this condition. Since it can be implied only on RFS, modifiers cannot be applied. The next condition is symmetrical. The symmetric condition is represented with a symbol as shown in the picture. It is a condition where the median points of all opposed or correspondingly located elements of two or more features are congruent with the axis or the center plane of a datum feature. As mentioned, symmetrical tolerance and the datum reference can apply only on an RFS basis. The picture shows the inspection method for a symmetrical condition. The symmetrical condition can only be applied for a symmetrical geometries. It should be represented only on feature of size, not for a feature. It requires a datum. Since it can be implied only on RFS, modifiers cannot be applied. Next is the positional tolerance. The position tolerance is generally represented for the whole. The positional tolerance can be applied only for feature of size, not for a feature. It requires a datum, and modifiers can be applied for the positional tolerance. Next comes the runout controls. The runout can be classified into two: circular runout and total runout. The circular runout is represented with the symbol as shown. A circular runout is a combination of symmetry and circularity. The difference between a circular runout and a total runout is a circular runout will check only for one point on the surface, whereas the total runout will check for the complete cylindrical geometry. Or we can say the total runout is a combination of cylindricity and symmetry. The following picture shows how the runout can be applied. To conclude, the circular runout can apply only for a feature of size, not for a feature. It requires a datum, and modifiers cannot be applied for a circular runout. Similarly, for a total runout, it can be applied only for feature of size. A datum is required for applying the total runout. Since it can be implied only on RFS, modifiers cannot be applied. Next comes the profile controls. So profile is the outline of an object in a given plane. Profiles are formed by projecting the three-dimensional figure onto a plane or by taking the cross-sectional requirement. Profile controls are generally applied for sheet metal geometries. It is classified into two: profile of a surface or profile of a line. The profile of a surface is represented by the symbol as shown in the picture. As I mentioned, the profile of a surface can be used to represent the shape of a sheet metal geometry. So this profile of a surface condition can be applied only for a feature, not for a feature of size. It can include a datum or not, it's a choice. Since it implied only on RFS condition, modifiers cannot be applied for profile of a surface. And similarly, a profile of a line, the difference between a profile of a line and a profile of a surface is the profile of a line will check only on one section of the geometry, whereas profile of a surface checks for the entire surface. As mentioned earlier, the profile of a line can be used for checking the sheet metal geometrical shape. It can be applied only for a feature, not for a feature of size. Datum requirement is optional. Modifiers cannot be applied for a profile of a line condition. Now we can start working on workshop number 15. In workshop number 15, a drawing is given with the symbols applied. You have to mention what is the meaning of the symbols. Once you complete workshop number 15, you have to complete workshop number 15A and 15B. After completing this, you can switch over to workshop number 16. In workshop number 16, the conditions is given in the first page. In the next pages, the drawing with the frame is given. So you have to fill in these frames with the appropriate geometric symbols. Once you complete this, you can check the values in the completed datasheet available in ORG.